and it's very rubbly because this is essentially the sediment that was being carried in the floods. We don't know what caused these floods. We can only assume that some of that water is now encased within the subsurface of Mars as permafrost. But in any case, as the floodwaters subsided, they built this gravelly, bouldery landscape that we see here. All right. Now, let's talk about some floods on Earth. This is a satellite photograph taken of Pacific Northwest from 500 miles up. And if you look carefully, you're going to see some dark areas that have all the characteristics of a branching stream pattern, except on a scale where the streams are hundreds of miles wide. And this was something that has become apparent as we go into outer space and we have this perspective of our planet and we look back at it. We're beginning to see things now that people couldn't see before because we were too small and too close. But what we're seeing here is evidence of gigantic floods. And here they show up quite conspicuously in this color satellite photograph. You see, what you have here is the red areas are being intensively farmed. They're agricultural areas, hence the red is a warmer area. And this is where the topsoil, this 100 to 200 foot thick layer of topsoil, has been stripped away to expose layers of black basalt, which is lava rock. And this is essentially a graphic of what we were just looking at. There's an area, who's heard of the Channel Scablands? Anybody been out there? Anybody been to the Pacific Northwest?
Yeah, my car ran out of gas out there. It's just a big desert.
It's a big what?
It's a big desert.
Yeah, it's basically a big desert. But you probably didn't know what process created that big desert, did you?
It has something to do with Coeur d'Alene, that the glaciers melted.
It did have something to do with that, yes. Okay, well, okay, so there you see basically the configuration of the glaciers, and what we see is that these were meltwater streams. I was talking before about some force that caused this rapid melting of the glaciers. Well, as the glaciers melted, these meltwater streams poured off the glaciers, going towards the oceans to bring the ocean levels up. What would these floods look like if we were seeing them from the ground? To a witness, if you were one of the Clovis people living in North America at that time who maybe survived this, what would you have seen? Well, that's what I'm going to try to show you. If you go out west and you actually stop and pause and take a good look at the landscape around you, you'll begin to notice stuff like this. Strand lines on Mount Jumbo. This is a mountain in western Montana. You see those lines? You see the horizontal striations? What are those? Those are shorelines. And as it says in Genesis, the waters prevailed exceedingly and all the high hills were covered. Well, in some instances, that is literally true. And we see it happening. And there's the mute evidence, the testimony right there when we look at the sides of the hills. They show up very dramatically, like in the case where you've got some melting snow on them to very prevalently define the layers. There's current ripples. This was a few years ago when Hurricane Ivan came through here. It dumped more water on the Chattahoochee watershed than had been dumped on here for probably 100 years or more. And for somebody who studies paleohydrology and the effects of water flows like myself, it actually was quite a boon because I was able to go and visit a lot of the creek channels and so forth to study what had actually happened. This is actually the old floodplain just next to a baseball field. The waters rose up over the old floodplain, laid down this layer of sand, and left these ripples. By looking at various kinds of evidence, I was able to determine that the water over this sand here was 23 inches deep, almost 2 feet. Well, when you look at a ripple phenomena like that, you've got two things. You've got the amplitude, which is the difference from trough to height, and you've got the wavelength. And you've got about a 3/4 inch amplitude here and a wavelength of about 2 to 3 inches. And this is in a 2-foot depth of water that's probably moving fairly sluggish at 5 to 8 miles an hour, somewhere like that. So you can picture this 2-foot deep of water, and then you picture the amplitude of the current ripples. Scale and variance. I'm going to show you a very interesting example of scale and variance now. What's this? This is a prairie in western Montana, and what do you see on that prairie? Ripples. You see the farms and the roads. What size of ripples are we talking about here? How about this gravel bar? Well, here for a little scale, there's a 3-story, that little dot right there, I don't know if you can see it, that's a 3-story building. We're looking here at amplitudes of 30 to 50 feet, wavelengths of 2 to 500 feet. Kind of a water flow builds something like that. It's like no water flow we've seen in historical times, I can assure you of that. But there it is, and if you know what you're looking at, it's unmistakable, unmistakable. That is a gravel bar. And it's 4 miles long, and it's mantled by these giant ripples. And here is looking at a section of these ripples, and to try to give you a sense of perspective, you notice the human figure right there? Can you see that little dot? Okay, look at the size of those ripples, and try to imagine what kind of a water flow would have created that. Well, by looking at the size of the channel, the uppermost level of water erosion, by looking at the scale and magnitude of those ripples, by taking the gradient of the stream channel, one can compute a peak discharge. How much water was flowing in there? And this has been done. Well, to give you an idea, if you took every single river on Earth, every single stream, every creek, every bit of flowing water, and I'm talking about every continent, all the big rivers, from the Po to the Indus to the Euphrates to the Amazon to the Nile to the Mississippi to the Columbia to the Mackenzie, et cetera, et cetera, et cetera, all of that together wouldn't even be 1/20th of this flow. So how do we explain this by reference to known phenomena? We don't. All right, now here we see what's called an erratic boulder sitting on the side of a big hill. And if you look carefully, you'll notice that there are other big erratic boulders perched around on the hillside, even up to the very top of this 1,000-foot tall hill. We see, now, how big is that boulder and how did it get there? Because that boulder is not part of the bedrock, it's just sitting there on the side of the hill. Like if I took this globe here and I went up and I set it on the side of the hill. All of those rocks have just been placed on that hill. By what force or means were they placed there? And how big are they actually? Let me give you an idea. I'm going to actually, there was 2 people in this picture when I took it, so let me put them back in. First of all, okay, here's the rock, and there's the people. Well, the slide I just jumped past is how we put those rocks there.